Most people think better models come from better algorithms. That's wrong. In reality, most of the performance in data science doesn't come from the model. It comes from the data you feed into it. And that's where feature engineering comes in. It's not a fancy term. It simply means transforming raw data into meaningful inputs that a model can actually understand. If you get this right, even a simple model can perform extremely well. If you get it wrong, even the most advanced algorithm will struggle. Think about this in a simple way. Imagine you're trying to predict house prices. Raw data might include things like total area, number of rooms, and location. But on their own, these might not be enough. Now imagine you create a new feature like price per square foot or distance from city center. Suddenly, the data becomes more meaningful. You're not just feeding numbers, you're giving context. That's feature engineering, turning basic inputs into smarter signals. This idea has been central to machine learning for decades. Researchers like Pedro Domingos have emphasized that the quality of features often matters more than the choice of algorithm. Because models don't understand data the way humans do. They rely entirely on the features you provide. If those features are weak, incomplete, or misleading, the model has nothing useful to learn from. In practical terms, feature engineering includes things like creating new variables, combining existing ones, encoding categories into numbers, normalizing values, or extracting useful patterns from text, dates, or images. For example, instead of just using a date, you might extract the day of the week or whether it's a holiday. Instead of raw text, you might convert words into numerical representations. It's all about making data more usable for analysis and modeling. But here's the part most beginners miss. Feature engineering is not just technical, it's creative. You need to understand the problem deeply to know what features might matter. Two people can work on the same data set, and the one who thinks better will create better features and get better results. That's why this step is often what separates average work from high-impact work. Now, with modern AI and automated feature selection, some parts of this process are becoming easier. But the core thinking still matters. Tools can suggest features, but they don't fully understand context the way humans do. That's why companies still rely on people who can connect data to real-world meaning. At the Learning Studio, the goal isn't just to explain techniques. It's to show you where real value is created. And the truth is, feature engineering is one of the most underrated skills in data science. Because once you understand how to shape data properly, you stop depending on complex models and start building systems that actually work. And that's what makes the difference between someone who runs models and someone who builds solutions.